The chip powering ChatGPT contains more transistors than there are stars in our galaxy. Here's how engineers actually build something that complex. Traditional computer chips process information sequentially, like reading a book one word at a time. Neural processors work completely differently. They're designed to mimic how your brain processes information, handling thousands of calculations simultaneously across parallel pathways. Inside an AI chip, specialized cores called Tensor processing units arrange transistors in dense matrices, with each cluster dedicated to multiplying massive arrays of numbers at once. This is why a single AI chip can evaluate millions of possibilities in the time it takes a conventional processor to handle one. Building these chips requires precision that makes watchmaking look crude. Manufacturers use extreme ultraviolet lithography machines that cost over $200 million each. These machines fire light with a wavelength just 13 nanometers long through a series of mirrors smoother than any surface found in nature. The light etches patterns onto silicon wafers where individual features are 500 times smaller than a red blood cell. A single speck of dust would be catastrophic, which is why fabrication happens in clean rooms 10,000 times cleaner than a hospital operating room. The real breakthrough isn't just cramming more transistors together, it's how they're connected. Modern AI chips stack memory directly above processing cores in three-dimensional towers, cutting the distance data travels from millimeters to micrometers. This architecture, called high-bandwidth memory, lets information flow at over 1 trillion bytes per second. Engineers also design custom pathways, optimized for the specific mathematical operations neural networks need most, like matrix multiplication and activation functions. The result is a chip that can train language models or generate images using a fraction of the energy a conventional processor would burn. What makes this entire process possible is a feedback loop between chip design and AI itself. Engineers now use an artificial intelligence to optimize the placement of billions of components on each chip, a task that would take humans decades. AI algorithms determine the most efficient routing for thousands of kilometers of microscopic wiring, predict thermal hotspots before the chip is manufactured, and even suggest new architectural patterns that human designers never considered. The chips that run AI are increasingly designed by AI, creating a cycle where each generation becomes exponentially more capable than the last. That galaxy of transistors isn't just impressive engineering. It's the foundation of every AI breakthrough you've seen in the past 2 years. And the next generation is already being designed. If you want to see how the technology behind AI actually works, subscribe and hit the like button.